You've now been told a lot about how to use our 3 databases by using graphical user interfaces, using the websites. And I now want to introduce you to using APIs. And for that, I'm going to start at the very beginning. So API stands for Application Programming Interface. And APIs basically are sets of procedures that allow applications to communicate with each other. So what that means is that the procedures can be used in code to communicate with an application like a software or a website like our databases. And that means that with our database APIs, we can now write code that automatically requests information from them. I'm going to introduce you to each of the 3 databases APIs, and I'm going to start with StrainInfo again. On the StrainInfo website, you can click on the Web Services tab, and then you get to the documentation for the StrainInfo API. APIs usually have several different endpoints or network locations that requests can be sent to, and you can see all of these endpoints of the StrainInfo API listed here. And for each one, you can uncollapse here a section and then see even more info. The first batch of endpoints is for requesting some simple statistics on StrainInfo. So for example, the total number of strains in the database, the number of type strains, cultures, and so on. And when you uncollapse this here, I have now uncollapsed the section for the count strains endpoint, which is for receiving the number of strains in the database. You can actually test this out by simply clicking on execute. APIs work by sending requests through URLs, and you can see the URL for making this request here. So this URL consists of the base URL for the StrainInfo API, the version number of the API, and the endpoint that we're using, which is count strains. And when we send off this request, we receive back an answer in JSON format. In this case, it is just one number, which is the number of strains in the database. You can also simply use your browser to make an API request by simply copying this URL into the address bar. And then you also get the number back. The same, of course, also works for all the other count endpoints. Then we have a distribution endpoint, which is also for receiving back a statistic. In this case, the distribution of cultures over the strains in the database. And then we come to the search culture endpoints. With these methods, we can search for StrainInfo culture IDs, for example, for all cultures of a given strain, searched by either the StrainInfo ID or a culture collection number or another designation, or we can search for all cultures of a taxon, for example, of a species or a genus, or we can search for cultures that are connected to a certain sequence accession. So when I open this up here, now it is, of course, a little bit more difficult because we have to give a parameter here, which is the ID we want to search for. In this documentation and test environment, we can actually just put a number, so in this case, a StrainInfo ID that we want to search for in this field. And when I click on execute, it is actually automatically added to this request URL. So again, we have here the base URL for the StrainInfo API, the version, the endpoint. We want to search with a strain ID, and in this case, the ID we want to search for is 5. And again, we receive back now a list of culture IDs, which are all the cultures that are the cultures of the strain with the StrainInfo ID 5. Then we can, of course, also do this with the other endpoints, for example, with the taxon. here you can also simply put your taxon name, for example, a species name, into this field, and it is automatically added to the URL. So this is just a coded white space. And again, you receive back a list of all the cultures that are of this species in StrainInfo. Once you have the culture IDs of the cultures you are interested in, you can then go to the culture data endpoints. So here you can request the information on the cultures that StrainInfo has. So there are 3 different methods, and the difference between them is in how much information they give out. So max simply gives out all the information that is present on a culture in StrainInfo. Average is a little less information, and minimum only, yes, a minimal set of information. So in this case, I want to show you this again in the browser by typing it into the address bar, for example. So I have now here the base URL of the API, and now I define which endpoint I want to search with, which is I want to have the maximum amount of information. And just for the example, I just put in 1. So culture for the culture ID 1 in StrainInfo, I now want all the information that is available. So information or data is always returned in as a JSON string. This is basically what a JSON string looks like. Yeah, just a long string of information. This is very well readable for a computer, but not so much for us humans. So to make it more readable, viewers and browsers usually format it a bit different. For example, here I'm using Firefox browser, can just click on Pretty Print, and this is the same string. It just has added lots of line breaks and indents to make this more readable. And we can now here see what kind of information we receive back. And Firefox even has a JSON interpreter. When I click here on JSON, it transforms this information into a collapsible string where we can really have a good look at the information. I like this when I work with a new API or a new endpoint. We can really just check what kind of information is returned to you and how it is formatted. And with this example, I come back to the documentation page here. There's one last endpoint, which is the archive. And this endpoint can return strain information from the StrainInfo archive, which holds all the current strain information, but also all previous versions of strain data. And you can search here with an SI ID. In this case, you have to also add the prefix and version number, because, as I said, all the different versions of strain data are stored here. So now I showed you how to try this out in the documentation and a bit in the browser. But of course, what we also really want is to use this in code, in scripts maybe. And I want to show you some examples in Python today, which is my language of choice. To make API requests in Python, I'm using a package called requests, which I import now. And I want to search for our example strain, which again is Prevotella bivia 653C. I store in a variable the designation 653C. And with this designation, I now want to make an API request. So I use from the requests package the get method, and as a parameter, give it the URL I want to request with. So this again is the URL that I have explained before. So the base URL for the API, the version 1. Then I want to search for a culture, and I'm searching with a strain designation. And with the designation, I just stored in a variable. So I run this. I don't see anything now because I stored the response in a variable called response. I can print this out using a JSON decoder that is implemented in the requests package. And now that looks like this. What I received back is a list of StrainInfo culture IDs that are the cultures that are connected to the designation that I searched with. So to go on, I'm just going to store the first of these culture IDs in a new variable. You can see here. So I have my variable with the first of the culture IDs. And then what I do next is I make another API request, this time to the data culture endpoint. And with this StrainInfo culture ID as the culture ID I want to search for. So I now request all the data StrainInfo has on this culture with this ID. And again, I store the response in a variable called response. And when I now print that, I get all this information or all this data that is in StrainInfo on this culture. And the JSON string is now basically a nested list of nested dictionaries and nested lists in Python. So it's a lot of information. It's not always easy to find what you're looking for. Usually it's lots of looking, trying out what you want, where you can find that, how you can access that. For example, I now want to store the StrainInfo strain ID of the strain that this culture belongs to. I can see here that it is somewhere here under strain and ID. So I've now already prepared, of course, how exactly I can get to this ID. And I again store that in a variable. So this is now our SI ID for our example strain, the Prevotella bevia strain. And I could also print out other things or store other things. For example, here I want to print out the culture collection number or designation of the culture I had now just looked at. That was NCTC1156. And I can also get all the other designations that are used for the same strain as a list. And for the end of this StrainInfo API introduction, I want to also store the BacDive ID of the strain. Exactly. And with that, I now go over to BacDive. So we come to the BacDive API, like StrainInfo on the BacDive website. You can also just click the Web Services tab to get to the documentation of the BacDive API. What is different in BacDive is that in order to use the API, you need to be registered and logged in. But that's nothing to worry about. You just click here and you can log in with, for example, a Google login or a Life Science login, or you can just register right here. It's just a short registration form. And when you send this off, you almost immediately will get a confirmation email. And then you can log in and start using the API. So I have to log in. All right, and now I can use the API. The BacDive API also has 5 different endpoints. The first one is called fetch, and this is the most important one. It returns detailed information on a strain, but the strain needs to be searched with a BacDive ID. And like in StrainInfo, you can also see an example in this documentation when you click on example here. But by the way, you can also only see these examples if you are logged in. you can also, of course, again, simply type an example into your browser. I'm just going to copy the base address for the API here and then add fetch. And then I'm now also looking for the Prevotella strain. This is the BacDive ID of our Prevotella strain that I just found in StrainInfo. And when I now click enter, I again get a lot of information, which is basically everything that BacDive has on the strain. So we have here the same sections that you can also see when you view a strain page on the BacDive website. Most is filled out, but there's actually one thing that is missing, and that is the predictions. By default, the predictions are not returned with the API. You can turn them on by adding a special flag, which looks like this. So you add a question mark, which starts where the flags go in API URLs, and then predictions equals 1. And when I now click enter and look at the results I receive, I can see that the predictions are now here in their own section, and they're also within the usual fields, just like on the website, where they're also within the data, basically where the kind of data belongs, and also at the very bottom in their own section. Every JSON file that is returned for a BacDive API request has these 4 main fields. Count basically just tells us how many entries were returned. In this case, just 1, because I searched for just one strain. You can also search for more than one. They just have to be comma separated. So for example, I can do this, and now I have 2 strains. The next and previous fields are empty now. They become important when a lot of entries are returned. So we have a pagination that comes into effect if there are more than 100 entries returned. Then there are only 100 entries on one page, and these 2 fields then contain the links to the next page or the previous page. And the actual data is, of course, in the results field. Here now for 2 strains. Yeah, but as I said, in order to receive this data on BacDive strains, you have to search with a BacDive ID. Usually, of course, when you come to BacDive, you have some other identifier, but you probably won't know the BacDive ID. So then you can use one of the other 4 endpoints, which are search for culture collection numbers, taxonomy, or sequence accessions, and these return BacDive IDs. So for example, with the culture collection number endpoint, you send a request to this endpoint with a culture collection number, and then the result that you get back will be a BacDive ID. And the same also with the other endpoints. For example, the taxonomy endpoint. I can now look for all BacDive strains of the genus Prevotella. When I send this off, I get a long list of BacDive IDs. So we have 181 Prevotella strains in BacDive, and here you can also see the pagination now. So on this page, we only have the first 100 entries, and then you have to click this link to get to the next page of the remaining entries. And with that, I have shortly explained all the different endpoints, and I again go to my Python console. Because of the required login for the BacDive API, making requests in Python also works a little different. the coding of the login is often not that easy. And because of that, we actually have created a special Python package that we offer, and that helps to do that. That package is called BacDive, and I'm just loading it here. And with this package, I can now initialize a BacDive API client with my login data. So from the BacDive package, I now use the BacDive client method and initialize that with my email address and password. So you can see this was authenticated. I am now basically logged in. And for my first example, I simply want to make a search with the BacDive ID. This Python client for the BacDive API has two different methods. The search method, which takes as input any kind of the same inputs as any of the 5 API endpoints. So BacDive IDs, culture collection numbers, sequence accessions, and also taxon names. And it fetches and stores the BacDive IDs for all strains that were found in this search. And then you can use the retrieve method to retrieve the information for these strains that were stored. So for my first example, I simply want to make a search with the BacDive ID. So with the client that I initialized, I now do the search method. I'm searching with an ID, and I'm using the BacDive ID that I just stored in this BacDive ID variable using the StrainInfo API. I get a 1 in return, which simply means that one BacDive ID was stored by the search method. And now I can use the retrieve method to retrieve the data for that strain. Again, that's all of the data that BacDive has on the strain, so it's a lot. But also, as shown before, the predictions are not by default included in this. If I want to have the predictions included, I actually have to turn that on before I retrieve data by using this include prediction method. And I can now do the retrieval for the strain again. But now I don't want to print out all the data again, but just the predictions to show you that they're actually there now. And they are there, looks like this. And I can also now turn off inclusion of predictions again by using exclude predictions method. So what I here just did was I retrieved all the data of the strain, but I chose to only print out a small part of it. I can also use filters in the retrieve functions to only retrieve the part of the data that I actually want to use. So for example, here I am again going to retrieve the data for the strain, but in this case, I only want to know what species this is, some keywords on it, and what culture mediums I could use for it. And when I print out, then it looks like this. So I do have my keywords, my species name, and some culture medium information. And what I'm going to do next is I'm basically doing the same retrieval again, but I'm not going to print out the strain, but store the species name in a variable called species. This should be Prevotella bivia. Again, how to get to exactly this information that you want in this nest dictionary of lists and dictionaries is not always that easy. It's a lot of just looking at it and doing trial and error, but usually you will find out at some point. So I have stored now the species name Prevotella bivia, and I'm just going to do one more search with the BacDive API. this time with the taxonomy and with the species variable I just stored. So basically, I'm now asking the search function to search for all BacDive strains of this species. It has found 19 strains, and of course I can retrieve those again, but for now I just want to retrieve the BacDive IDs of all these strains. And so here I get now all BacDive IDs of the 19 strains of species Prevotella bivia that are present in BacDive. And if you want to know more about the Python package for BacDive, we actually have a tutorial on this that you can find here on BacDive under tutorials. Yes, it's a whole video just on the Python package, and there's also a second video on the R package that we also offer. So if you would rather use R than Python, you can watch this video and also find a lot of info on how to use that. I just had already printed out some information on media that could be used to culture our Prevotella bivia strain. But of course, as we have seen before, we could get a lot more information on this on MediaDive. And on the MediaDive website, the API documentation is a little more hidden. You have to click on Manual and then API reference to get there. Then it looks like this. The documentation here starts with a short explanation of what a JSON-formatted response to a MediaDive API request will look like. Again, there are three main fields. In this case, the first field is status. So I haven't talked about the status of API requests before because they are not returned as part of the JSON data for the other two databases. A status of 200 or 200 means that your request went through okay and there was data received back. And then in this case, you have the other two fields. Count works the same as in BacDive. So this is the number of entries that was received. And the actual data is in the data field. If you have a status 404, that means that you were looking for a data set that doesn't exist. So for example, you searched for an ID that is not actually present in the database. And a status 400 means that there was something wrong with the URL you tried to use to make a request. This API, of course, also has different endpoints. You can see them all listed here on the left sidebar. And like in StrainInfo, the first one is to receive some simple statistics or counts, numbers on the data that is stored in MediaDive. You can see how the information that is returned will look like down here, with explanations of what the fields mean right above that. And also, of course, the URL for this request. So in this case, the base URL for the MediaDive API is the normal URL for the website, and then at REST, because it is a so-called REST API, and then behind that, the name of the endpoint, which here is stats. So after these statistics, the next endpoints are the media endpoints. With the first one, you can simply get a list of all the media that are present in MediaDive with some simple minimal data on them. And the actual data on specific media you can get with the medium or medium recipe endpoint. Again, we can try out this endpoint right here in the documentation. For example, we can add an ID, so a MediaDive medium ID here in this field, and send a test request and see what the response to this request is going to look like. We can, of course, also again test this out in the browser. We just copy this URL and put in an ID instead of the placeholder. And now we have here the 3 main fields and the data that is returned to us for this request. The next endpoint is medium composition. Here you can see the different concentrations of the ingredients in the medium. And with the medium strains endpoint, you can request a list of all the strains that use a medium. The solution endpoints are similar, so we can request a list of all solutions that are in MediaDive, and we can request solution recipe of a specific solution. Then the same also for the ingredients. So we can request a list of all ingredients, or we can request detailed information on a specific ingredient. And last but not least, we have the strain information endpoint. Here we can request information on media used for a strain and the strain's growth on them by giving a strain ID, which can be a MediaDive strain ID, a DSM number, a JCM number, or a BacDive ID. And this is what I want to do now in Python. So to use the MediaDive API, I'm again using the requests package that is still loaded, so I can start making an API request. And here I'm now using the strain endpoint, and I want to search with a BacDive ID and with the BacDive ID that I have stored using the StrainInfo API. Again, I store the response in a variable, and I now print out the variable. So this went through okay. I received data back for this strain, which is also the correct strain. That was our example strain that we are working with here. And I now have the data on which media this strain can grow according to MediaDive. There are several media given. For now, I will just store the medium ID of the first one, which looks like this. Because I now want to make another API request using the medium recipe endpoint and requesting the medium recipe for this medium that we can use to culture our example strain. So this is now the full recipe for the medium. And we can, of course, also pick out different things to look at here or print this more prettier so that we can actually read it and use it to make a medium. I want to make now a last API request, which is I want to use the medium strains endpoint to get a list of other strains connected to this medium. So all other strains that according to MediaDive can grow on this medium. And this is also a very long list of strains given by their MediaDive ID. We have their species names, their culture collection numbers, they grow on the strain, BacDive IDs, and their bacteria. And with that, I'm basically done with my little demonstration of all the different APIs of our 3 different databases. So I just want to show you one last thing. I wrote a bit of code, a little script that uses all the 3 different APIs. And I'm not going to explain the code, but I just want to run this to show that you can actually do cool things with APIs and get information on strains. So here I want to print out all the Prevotella bivia strains that are present in BacDive, and for each of them I print out the strain name, the BacDive ID, where they were isolated and when, if this information is present, and which medium we can use to grow them. Yes, and with that, I come to the end of my presentation.